Okay, so for a continuous time signal x of t, a continuous time Fourier transform x of j omega is defined as integral minus infinity to infinity x of t into e power minus j omega t dt. So let us take a small example with x of t is equal to e power minus a t u of t. Let us assume that a is greater than 0, so that the plot of which will look something like this. So as the signal exists from 0 to infinity, the Fourier transform, the integral in the Fourier transform will be from 0 to infinity e power minus a t into e power minus j omega t dt. So this will be equal to integral 0 to infinity e power minus of a plus j omega t dt. So this will be equal to e power minus of a plus j omega into t by minus of a plus j omega, and limits will be from 0 to infinity. So this will be equal to minus 1 by a plus j omega into 0 minus of minus 1. So this will be equal to 1 by a plus j omega. So this is one example. Similarly, let us take one more example, that x of t is equal to rect of t by 2t. So it is a rectangle signal from minus t to capital T with amplitude of 1. So obviously the corresponding Fourier transform will be from minus t to, the integral in the Fourier transform will be from minus t to plus capital T. The amplitude of signal is 1 into e power minus j omega t dt. So this will be equal to e power minus j omega t by minus j omega integral minus t to, the integral limits will be from minus t to plus t. So this is minus 1 by j omega into e power minus j omega into capital T minus e power j omega into capital T. So this will be equal to minus 1 by j omega into minus 2j sine omega into capital T. So finally this will be equal to j will get cancelled out, minus 1 into minus 1 is plus 1. So this gets simplified to 2 sine omega t by omega. Thank you.